The one I want to go over is the parallelogram one. It says two consecutive sides of a parallelogram are 5 and 7. And the distance between the two sides that are 7 is 4. And then this time it didn't ask you for the perimeter, it asked you for the area. I think this is the same parallelogram, but it gave us one other piece of information, and that was what? Or did it? No,
That's it.
that was it on this one. So what do we do? 7 times 4, because our area formula for parallelogram is base times height. Our base is 7, our height is 4. And some of you are saying, can't the base be 5?
Well, it could be if you used a different one.
It could be, but if it's 5, I'm going to have to use this perpendicular distance between these two bases now, right? If I'm going to, and I don't know that, so I can't use it, but I could. This could be the base, in which case this would be the height. Problem is I don't know enough in this problem to get it. But if I use this as the base, the corresponding height is 4. Okay? That's the one I need to go over, just looking at how many missed the problem. Does anybody want to ask about any of the other ones? You figured it out then? That's what I'm assuming if you... Okay. It's all right to miss one here and there on these quizzes, but if you don't know why you missed them, then the errors get perpetuated as you move forward. So, okay. What I'd like to do next is I'd like to talk about the hot tub problem. The one that we gave you at the beginning of the semester. There were a number of things that we asked you to find, and at that time, at the beginning of the semester, we did not know how to do very many of them. Are we able to do them now, or are we... Who's got that problem out? We describe our hexagonal hot tub. There's the hexagonal prism that represents our hot tub. What do we know about it? Have you got some data? Somebody got that problem there?
Each side is 10 feet.
So 10, 10, 10 all the way around, right?
And the hot tub is 4 feet deep.
4 feet deep. And what are we asked to do? What do we need to know about it? How much paint we need to paint the inside. We've got a waterproof paint, right, that we're going to paint. So what kind of a question is that? Is it a perimeter? Is it a surface area? Okay. So, surface area. Now, I've taught, I was going to say this course, but even high school geometry enough to know that students think that formulas are everything. And so they try to memorize these formulas, and then they apply them mindlessly. What do I mean by that? Well, if we do the surface area of a hexagonal prism, a regular one, the formula is what for the surface area? If it's a regular, that means the hexagon's regular, how would we do it?
The area of the base.
Okay, so it would be
Base.
base,
And, yeah, and then, is that height? It's not height, that's volume. And the area of the other base,
So 2B.
so 2 B's, right?
and then the area of the.
Because can you see I fold my net out, and there's one on top and one on the bottom, right? And what else have we got? The sides, and that's what? 6. And so it's plus 6 what? The
Area.
side length times the height, right? So it'd be 10 times 4, we'd have 40 here, times 6, right? So they memorize that there's 2 bases and 6 sides, and then they mindlessly say, we're going to paint this all. What's wrong with that?
Painting the outside.
Huh?
That's painting the outside, number 1. We want the inside.
I think the inside of this is going to be about the same as the outside, just,
But we only have one bottom on the inside.
oh. Yeah, I see, and you're saying you don't paint the bottom?
No, we'll paint the bottom, but we won't, there's no top to paint.
Oh.
Since we're doing the inside.
Does everybody see what he's talking about? So, do we need 2 of these? That's what I mean by mindlessly. You just say, oh, well, they're... So, our situation, we're not going to do 2 bases. We're only going to do 1. We're painting the inside. Whether we paint the inside or the outside, there's only the bottom. There isn't the top. And it doesn't make sense to paint the top of the hot tub. Okay? So, we can use this as our guideline, but then we have to do it in a sensible way. All right, this one's pretty easy. What? 6 times 10 times 4. And we're only going to do 1 base, right? And how are we going to find it? We've done a problem like this in the homework. You should have at least one method. Is there a formula for the regular hexagon, the area of a regular hexagon? Yes, but we're not going to memorize it because it won't make sense to you. What are we going to do? We're going to divide it up. Yep. We're going to break it up into chunks whose sizes are shapes, or whose shapes are some things that we do know formulas for, and use the formulas for those. So what's your preference?
Triangles.
Triangles? Is that what you're going to say?
An equilateral triangle.
Equilateral triangles. So what I'm going to do is this is a 3D view, I'll just draw it from a bird's eye view.
Oh, that's actually really heavy.
6 triangles.
Uh-huh.
Now all we've got to do is what?
Find the area.
Find the area of one triangle and multiply it by 6. What do we know about any of these?
They're equilateral.
They're equilateral. How do we know they are?
Because
Because it's a regular hexagon.
So just because it's a regular hexagon, what makes that be equilateral triangles?
well, if we want to go a long way about it, we know that a hexagon has, at each angle, it's 120 degrees because of the formula that we used before.
This is 120.
Uh,
We could do the n minus 2, so 6 minus 2, right? Take that 4 times 180 and then divide it by 6, right? We'd get how big?
120.
120.
And then we're bisecting each of those angles, which will give us a 60-degree angle.
So that's 60, that's 60, that means that's 60, that's 60. That means that one's got to be. Does everybody follow his logic? Or we could say triangles come together at a point, and around a point, there's how many degrees? 360, and there are how many of those angles? 6, so they must each be 60. That means these two out here have to be 120, and since they're the same, we split it in half. That's another way of looking at it. So yes, we have an equilateral triangle, so let's blow that up. How big is this side? 10. How big is this side? 10. 10, because it's equilateral. Do we know how to find the area of that?
Yeah, we did it in the homework. What is it?
How?
It's the, what is it? N times the square root of n minus a minus.
If you do a lot of math, there is a formula for it, but memorizing it isn't going to work very good.
I always just do like a squared plus b squared equals c squared.
So, but that's for right triangles, and this is equilateral.
But if you like divide it down the middle,
Okay?
then you do a right triangle. So then you have 5.
So now I've got a right triangle, this one right here, that's 10 here, and how much there? 5, and an unknown, so I've got my A and my B, we'll call it H for the triangle, right? An unknown H. So what do I write?
5 squared.
5 squared
Plus h squared.
plus H squared, the two legs, equals 10 squared. And then we go 25 plus H squared equals 100. Then we do what? H squared equals
75.
75. So H is the square root of 75. Right? Which, since 75 is really 25 times 3, and that would be then radical 25 times radical 3, the radical of a product is always equal to the product of their radicals. And what's this?
5.
So that's 5 times radical 3. If you do enough of these, you'll know that every 30, 60, 90 triangle, on every 30, 60, 90 triangle, the hypotenuse is always twice the short leg, and the long leg is always radical 3 times the short leg. Always.
Well, that's nifty.
It's really handy if you do very many of these. But if you could just go back to the Pythagorean theorem, you don't have to have all these other things memorized. If you're going to be a secondary math teacher, you better get going on those. Okay. So now we can do this, right? This height is 5 times radical 3, so what do? We do the area of a triangle formula, which is
1/2 times 3.
1/2 base times height. So that's 1/2, what's our base? 10 times 5 radical 3. Well, half of 10 is 5, and 5 times 5 is 25 radical 3 is the area of one triangle, and I've got 6 of them. So 6 of these would be 150 radical 3 is the area of the lateral surface. Lateral means what again? Side, the sides. Now all we've got to do is put that together here, 150 times radical 3 plus this, which is what, 240? 150 radical 3 plus 240, and that's all in feet squared. Okay, this is a big tub, by the way. 4 feet means it's, let's see, there's 36, and another foot, it'd be about, it's this deep. I guess that's not too much deeper than thought. But yeah, 10, it's, you know, you can have a party there. Okay. What else do we need to do? We can paint it now, right?
how many gallons of water will fit in the tub.
Okay, what kind of a question is that? Volume. And if you don't know the answers to those questions, then you can't find it, right? If you don't know you're looking for volume or surface area or distance, perimeters or something, it's really hard to find. So what's our volume formula for a prism, a regular hexagonal prism? Area of the base, which we call capital B, times H. That's it. Well, guess what? We already have capital B, right? It is this. We found it when we found the surface area, right? Okay. So we'll take that, 150 radical 3, and multiply it by times 4, which makes what? 600 radical 3, and this is in feet cubed. What else are we going to do? So we're filling it, we're painting it.
What's the longest distance?
I was just gonna say, it says to find a circular patio.
Okay. Let's talk about that. What about that circular patio? Where would it be and how big would it be? You think it's going to be there? So where do you think it's going to be? Can I hold it up? She thinks it might be there. Does that look like where the biggest circle would go? You what? This actually ties back into our first unit. If I were to draw, extend the sides of this gazebo here, and this house, and this street, we have a what? A triangle. And this circle would be the inscribed triangle. And therefore, we could locate its center how? If it's the inscribed triangle, we're looking for the in-center. In-center, inscribed triangle. And how do you find that? Angled bisectors. Okay. And so if that would give us the biggest, we might try putting it a triangle out here like this, and could that be a bigger circle? Would that be a bigger circle? I don't know. So draw in a bunch of those kinds of triangles and then put the biggest circle in. So that's kind of where that tie goes. What else do we need to find?
What's the longest distance across the hot tub?
Longest distance across the hot tub. Where would that be?
From one vertex to the next.
One vertex to the next. That's pretty easy, right? This is 10, that's 10, that's 10 equilateral triangles, so that's 10, right? And that's 10. Well, what's that distance then? 20, that's pretty easy. What else?
What's the distance from the middle of one side to the middle of the opposite side?
From here to there. What's that? Is that also 20?
10.
Shorter or longer? We've already found that this, our height, was what? 5 radical 3. Well, if that is, then so is that. So what's that distance? 10 radical 3. Everybody with me? I think we're getting so we can do this. Have you got your list of formulas going? Every time we've discovered one and tied it back to mama or somebody that came from mama, have you made your list? Did everybody hear the question? Do we have to have these memorized for the test? No. I would only memorize mama. A equals L times W. And then you get on the test, if you don't remember them, just pull it back the way we did in class. Now, why do I say do it that way instead of make a list and go memorize it? Because then you apply it mindlessly. And you do two bases when there's not. Do you know what I'm saying? We could give you all different kinds of questions, and if you apply them mindlessly and just stick formulas in that you've memorized that don't make sense to you, you're not going to be very well off. So,
Bless you.
what if you get on the test and you go, I can't remember the surface area of a sphere formula? What are you going to do? You're going to cut an orange in half in your mind, and you're going to take your orange and you're going to what? You're going to stamp it, and you're going to trace as many as you can on a piece of paper, and then you're going to peel the orange and you're going to fill how many circles? Were you here that day? You're going to fill 4 circles, and you go, oh, I know the formula. It's what? 4 pi r squared. That's how you're going to remember the formulas. So don't just cram stuff up that doesn't have meaning. Put stuff up that's related to what we've been doing in class. Okay. We need to move on to our next topic.